Hello, my dear friend and or colleague. So you've heard about ECS, but you have no idea about what it is and how to use it. You might have heard that this has some components and entities, but how is this different from Unity components and game objects? Well, you can think about entities as super lightweight game objects and components as mono behaviors which contains only data. But why you should use it anyway? Well, short answer is it's faster and it has some architectural benefits for a project. So let's see how fast it actually is. In order to do so, let's create a simple comparison test. We will cover two main aspects, object creation and data access. I will start with object creation. So let's create a simple game object and a script where we will create a few game objects and entities and see how much time each of which takes. Creation test, I will call my script. And on start, we'll create a few game objects. 10,000 should be enough. That's it. And let's measure how much time it will take. Stop and put it directly to the backlog. That's it. And let's do the same for entities, but to make it a bit more competitive, let's create 1 million entities instead. 1, 2, 3, 1, 2, 3. Okay. To create an entity outside of the ECS systems, we need to access Entity Manager, which can be accessed via world, default game object injection world, that's a long name actually, Entity Manager, create entity. Okay, that's good enough for now. Okay, we have our game objects, 43 milliseconds, and entities 126 milliseconds. Well, considering that we created 1 million entities and it is only 3 times slower than creating 10,000 game objects, which is actually 100 times less. So, but we can do it even faster. We can use the overload of create entity method, where we can supply entity archetype and the count of entities which we want to create. So let's, in order to create an entity archetype, we need to go to Entity Manager, create archetype method, where we can supply like types of the components we want to entity to be created with, and I want 1, 2, 3, 1, 2, 3, 1 million entities, and we no longer need the loop. And I also would like to make a local variable out of the Entity Manager. Okay, we're ready to start. So now creating 1 million entities even twice faster than creating 10,000 game objects. Well, that's good enough already, but let's see how it works if we add a component, a single component on each game object. So let's go to our test, and instead of creating a game object and going to next one, we also will add some component. Let's create a component as well. I will call it test component, test mono behavior rather. For mono behavior, I also want to add int value on it for later test of accessing data and manipulating it, and I will create a struct component, test component for ECS component. Okay. So let's add component test mono behavior to gameObject. Actually, we also can supply it the creation method, but it's actually not any faster, and we have to supply a name for it if we want to add some components, which I don't want to do. And for entities, we can supply components we want our entity to be created with via the parameters of create archetype. We need component type. We need to supply an access for this component. If it's component which is only readed, we create read only. If it can be read or write to, we create it read and write test component. And I also forget to add a same public int value to ECS component. Okay, now we are creating 1 billion entities with some component and 10,000 game object with some component. Let's see how it runs. So creating game objects become, well, actually 50 times slower with single mono behavior, and creating entities basically the same amount of time, independent on what components are actually adding to it. Okay, good enough. Let's go even further and see how accessing the data and manipulating it behave. We will add an update method to test mono behavior, where we will increment the value of the component. And we will do the same for entity system component, but we need to create a system which will manipulate the data, because in ECS components can't have any methods. Well, they can technically, but they shouldn't. So let's create a class for system, test system, which should be derived from system base, and we need to create an onUpdate method which will be called every frame. To get our entities with a component, we need to access it via entities for each, where inside the lambda we have to supply. This is very describeful description. So how it actually works: you have a set of parameters you can supply or cannot, and you have to call run in the end. Well, what you can supply here: first parameter should be entity if you need one, or you can omit it if you don't need entity for this particular call. And you can supply what components you actually need. If you only read data from component, you should go with in test component. If you're going to read and write, read from it and write to it, then you have to supply it with ref attribute. Okay, let's do the same. So now our code is doing the same for mono behavior and for entity component, and let's see how it behaves. So let's run. creation basically the same, and to see the time for entity systems, we can go to analysis and entity debugger. Here we can see the time for all the systems. So updating 1 million entities, increasing the value. Here we have 1 million entities actually, and updating takes like half of a millisecond for all 1 million entities. And to see how much time it takes for mono behaviors to update, let's go to profiler. So let's pause our game and take some frame to analyze. So as we can see, the whole update loop takes, I also have some other systems running there, but main is this one, test system, half of a millisecond, and almost 3.5 milliseconds to update behaviors. Well, calling the update on each method is, well, the method itself is actually fast, but behavior update takes by itself almost 3 milliseconds, which is quite a lot actually, if you think about it. Even if you don't want to use ECS components because they're kinda limited, since you should use struct and you can't have all of possible data you have in mono behaviors, like links to prefabs or some materials or whatever, you still can have performance benefits of iterating all the components inside ECS system. You can do it by adding to gameobject a script. I will do it via code. I will add convert to entity script, and you have to supply an argument, a parameter for convert to entity if you want your game object to stay. So when you created the code, you need to supply conversion mode. Convert, so there are only two options, convert and destroy. This one will destroy game objects after entity creation, and it would add whatever components you have on a game object, and convert inject game object. We will leave game object as is and add all the components from game object to entity. So this way game object will stay and it will have test mono behavior script on it. So let's go to the test mono behavior and remove the update loop because we no longer need it, and go into ECS system, and instead of accessing test component we will use test mono behavior, and we don't need to supply in or ref since it's a class and it's always transfer the data via ref rather than value. So, but if we try to compile this code, we will get an error which says like entities for each use managed iComponent data test mono behavior. It's only support when using without burst and run. So let's add without burst here, and this will allow us to access test mono behavior inside the lambda inside system. Okay, so let's see how much time it will take this time. We have our game objects. The value is being changed every frame as expected, and let's go to the entity debugger and see that test system actually takes less than half of a millisecond for 10,000 game objects. And we also can see, if you go to all entities, we will see all entities which exist in our system. We have our entities with test component, which are now not updated because we changed it, and we have all the game objects somewhere. Let's go to the test system. If you click on a test system, you will select only entities which is affected by this system. So we have 10,000 game objects, and we can see all the components which added to the entity when it was converted from game object. So we have a transform, so we can actually access the transform inside the ECS. We have our test model behavior and some components which added automatically for game objects to control the transform of the entity. Another benefit of having the logic inside the ECS system instead of game object itself, you can always turn off some part of the logic. For example, if I want to stop it increasing the value, I can just toggle off the test system which do this and see that value is no longer being updated. So when I turn it on, it start to work again, on and off. This helps with debugging, and you always have more control on what you want to run and what you don't want to run. So system inside ECS is basically a singleton. You don't usually access it, but sometimes you can and should. For example, if you want to select something inside ECS world, you can have a method inside the system to access it and call this code outside of ECS environment. So let me stop the game from running, and for example I want to get a number of entities containing some component. I can do a public int entities count, and I want to get the count of entities which contain specific component. How I can do that? I can simply create a query. Oops. So it should be a method, of course. So I need to create a query. You can think about query as a simple SQL query you run on ECS data and get whatever data you want. You can create query via entity manager, create query, entity query, and you have two options. One is simple, second is a bit advanced. So we'll start with simple one, and we need to supply required components. Since I have it as a type parameter, I will just supply it as is, and I will do read only since I only need to read it. Okay, and now all I need is to call a method calculate entity count. So this will calculate a count of entities inside the query and return the value. And the benefit of it is that you don't actually query all the components, you just count the data. And it is much faster than iterating or getting the... Basically it's a getter for array length inside the ECS components array. So how we can access this method outside of ECS system? Very simple. I will do it here on start as well, and we can also measure the time, because why not, and do the same. and I want to call it a few times in order to see like how much time it will take. So to access the system, we can go to world, default game object injection world, and get or create system and supply a type parameter as a type of our system. So let's test system, and here I can access all the methods inside the system, and here I have my entities count method, and I want to count test component systems entities, and I want also to actually see if the value is correct, not just calling it, so I will also supply it to the backlog. Okay. Let's see how it goes. One million entities, as we can see, and time is only 29 milliseconds for 10,000 times calling the query of getting 1 million entities. And let's see if it actually affects the time if we have less entities, because I wonder if it has any effect. So let's create a 10 entities instead and call this method again. As we can see, it has some impact, but not as much. But actually, the main performance hit is inside creating the query. And since it's a bit of a static, most of the queries should be cached. Let's have a little cache inside our system. So I will have a dictionary where the key will be the type and the value will be entity query. So instead of creating an entity query each time, we can first try to get it inside the dictionary, and if it doesn't contain the query, then we should create it. Oops. And add to dictionary. Oops. Okay, looks good. Of course, remove this one and calculate entity count. Okay, and I also would like to replace all occurrences of type of T. So creating the query only when we never had this one, and then return. Let's see if it has any effect, and let's also return the number of entities we had. So now it's only 2 milliseconds to query it 10,000 times.